everyone, welcome back to another lesson. Today we're going to talk about geometric figures. This is going to be Module 2, Chapter 9. So first off, we're going to start out with angle relationships. It's honestly not too hard. First off, we're going to discuss the different kinds of angles that you can identify in a figure, and that'll help us find how many degrees each angle is, what each measurement of each angle is. So first off, we have our complementary angles, and those are going to be a total of two angles whose sum is 90 degrees. So for example, and we don't really have too much of a good example here in our model. Let me think. Angles 4 and 6 and 5 and 8 are both going to be two sets of complementary angles, and that's because whenever you put, oh no, I lied. As far as our complementary angles go, they're pretty much going to have a sum of 90 degrees. Now, on the other hand, our supplementary angles are going to be a set of two angles whose sum is 180 degrees. Now, this is where angles 4 and 6 and 5 and 8 create supplementary angles, because when you add the degree of 4 and 6 together, you get 180 degrees, and when you add 5 and 8 together, you should get 180 as well. So we're going to start off, we're going to look at our figure. If you'll notice, we have a couple of measurements in there already. For example, 61 and 63. Right off the bat, the two angles going across vertically, or not vertically, horizontally, are going to be parallel lines. And when we look at our measurements that we already have, we'll notice that 63, that measurement, and the angle right across from it too should be the same measurement because of our lines and our complementary angles. So right off the bat, we can assume that 2 is 63 degrees. We can assume that 9 is 61 degrees. After that, we can take a look at our supplementary angles, and we kind of find our measurements from there. We can also look at our complementary angles and figure out what matches and what's going to be the same measurement. So 9 and 4 are both going to be 61 degrees because of our parallel lines and that one intersecting line that makes them the same measurement. Next, after we figure out our measurement for angle 4, we already have our measurement for angle 2. If you'll kind of notice, this is pretty much making a straight line between 1, 2, and 4. Meaning that that whole angle, that whole area is going to be 180 degrees. So what we can do is we can add 63 and 61, and that should give us a measurement, and then we just subtract that from 180, and it should give us 56 for angle 1. Next up, we can determine what our measure for angle 7 is in our triangle. Because all triangles add up to 180 degrees, we can assume that 63 plus 61 plus angle 7 will make 180. So we add our 63, we add our 61, and that should give us 56 degrees as well. Also, if you'll kind of look, there's one line that intersects the two parallel lines. If you'll kind of look, you'll notice that angle 1 and 7 are going to be the same measurement as well. So that's another way to identify that measurement. Afterwards, we can look across from 7 and we see 12, meaning that 12 will more than likely be the same measurement, 56 degrees. Next, we can look at our supplementary angles. So angle 7 and 8 and 11 and 12, or you can do 8 and 12 and 7 and 11. Regardless, those sets of numbers are going to make 180 degrees. So what we can do is subtract 56 from 180, and we should get 124 for angle 11 and 124 for angle 12. Next, okay, we can assume, let me get this up. When we look at our angles, we just solved for 124. We'll notice that 8 and 5 should make a 180 degree line. They're going to be supplementary because 5 and 12 are complementary. Meaning that we can do 180 minus 124, and we should get 56 for 5. Which also another way to figure out the measurement for 5, you can look at the angle directly across from it, angle 1. We already solved for that, and that's 56 as well. Next, we're going to look at angles 6 and 10. You'll notice 9 and 6 and 10 and the measure of 61, or the other way around, makes 180 degrees because they're supplementary angles, which means we could technically do 180 minus 61, and that'll give us a measurement of 119 degrees for angle 6 and for angle 10. Next, we're going to talk about angle measurements and shapes. We start off with this triangle right here, and this starts out pretty easy, honestly. If you'll notice, we have one big triangle. It's filled with 2 small triangles in the parallelogram. What we're going to do, we're going to solve for angle A, that one missing angle in our big triangle that we don't have a degree measurement for. So all we do is we add 74 and 26, and then we subtract that amount, that total, from 180, and that should give us 80 degrees. Well, now we can look at our parallelogram. So if you'll notice, 2 and 7 are going to be the same measurement because they're complementary, and 1 and 5 are going to be the same measurement. So if 1 is 80 degrees, 5 is going to be 80 degrees as well. Now, and this is a fun thing, with parallelograms, instead of them being 180 degrees altogether with all their angles like a triangle, it's going to be 360 degrees. So what we can do, and I've got my calculator right here, we're just going to add 80 plus 80, and we know that angles 1 and 5 make up 160 degrees. So we can take that out of 360 minus 160, and that'll give us a sum of 200, which means the total, when you add 2 and 7, the total for those angles, it's going to be 200 degrees. An easy way to figure out what they are individually, because we don't want the sum, is we just need to simply divide that by 2, and that should give us a total of 100 for both angles. Now next, we're going to kind of take a look at our other angles, our supplementary angles. If you'll notice, 2 and 3 are supplementary. They're actually right next to each other. They're going to make 180 degrees. So what we would do is subtract 100 from 180, and 3 will be 80 degrees. Now after that, we have our top tiny triangle that we can solve for because we just found angle 3, and we already have angle C. So we add 80 plus 74, and we subtract that total from 180, and that's going to give us 26. And now what we can do is we can pretty much solve for 6, because we have angle 4, we have angle 5, we don't have angle 6. And we know that all 3 of them, when added together, are going to make up 180 degrees. So what we can do is we can add 80 and 26, and we could subtract that sum from 180, and that's going to give us 54. Well, now we have 2 angles for our bottom right small triangle. So what we can do is we can solve for angle 8 with our angle 6 and angle B that we already have answers for. So we're going to do 54 plus 26, and we're going to subtract that sum from 180, and that's going to give us 80 degrees. And that's just a little list of all the angles that we found in our shape, in our figure. Next, we're going to talk about finding measurements in a concave polygon. And this is actually interesting. We have a little formula that we can use, and it's going to kind of help us figure out how much each y is for our polygon. Concave polygon, I should say. So the formula we're given is 180 times n minus 2. N is going to be equivalent to the number of sides or angles of the shape. So when we look at our shape, we're going to count all the vertices. We have 1, 2, 3, 4, 5, 6, 7, 8. So our formula is going to look a little bit like this. It's going to be this formula right here. It's going to be 180 times 8 minus 2. So we're going to follow the rules of PEMDAS. We're going to do 8 minus 2 first since they're in parentheses, leaving us with 180 times 6. Next, we're going to solve for that, and we should get 1080. So that's going to be the sum measurement of our entire shape. Now what we're going to want to do is we're going to want to add all of our numbers next to our y's. That way we can solve for y. So a good way to do this is we have 3 7s, so 3 times 7. We have 3 3s, so 3 times 3, and we have 2 12s, so 2 times 12, which means we're going to have a total of 54 units that'll help us kind of solve for our y. So we're just going to divide that by 1080, and that should give us a sum of 20. So every y that we have on our figure is going to be equivalent to 20, which means now we can kind of solve for each angle. So we're going to solve for our 7s first. We'll do 7 times 20. That should give us a degree or an angle measurement of 140 degrees. Next, we're going to solve for our 3s. 3 times 20 will give us an angle measurement of 60 degrees. And then we're going to solve for our 12s. So 12 times 20 will give us 240 degrees for our angle measurement. And that's going to be the sum for our figure in total. Next, we're going to talk about finding measurements of interior, exterior, and central angles. And right here, if you'll notice, we're going to use the same formula again. Once you kind of get the hang of it, it's really not too bad. It's actually pretty fun to use. It's unique. Right here, we're given a nonagon. We've got 9 sides, 9 vertices, meaning that our sides or angles, our n in our formula is going to be 9. So 180 times 9 minus 2. Well, 9 minus 2 is 7. So we're going to solve for 180 times 7, and that should give us a total of 1,260 degrees for our angle. Well, we don't technically have, I should say, we don't have anything like 7x, 3y, nothing like that like we did in our last problem. We just have simple angles, vertices. So what we're going to do is we're going to divide by the total number of vertices that we do have, total number of angles. So we're going to do 1,260 divided by 9, and that should give us a total of 140 degrees for each angle in our figure that we have. Meaning that our question mark, let me see, our question mark right over here, it's going to be the furthest to the left, is going to be 140 degrees. Well, next, what we're going to do is we're going to solve for our question mark towards the center of our circle. And since this is technically the center of our circle, we can automatically assume that each line on the triangle that this creates is cutting our angles in half. So instead of the bottom left-hand corner, that angle of that triangle being 140, it's going to be half of the original angle measurement since it's being split in half, meaning that the bottom left is going to be 70, the bottom right is going to be 70, and then all we need to do is solve for our point. So we're going to do 70 plus 70. That'll give us 140 degrees altogether for the bottom part of our triangle. And then we're going to do 180 minus 140. And that should give us an angle measurement of 40 degrees. Now again, what we can do, we know that each angle, inner angle of our nonagon is going to be 140 degrees, right? Well, we have a line going across the bottom of our nonagon. And when you compare it with the side of the nonagon, you'll notice that our question mark and our 140 degree angles create a supplementary angle on the bottom, right along here. What we can do is we can subtract 140, since we know that this angle right here is going to be 140. We can subtract that from 180, and that's going to give us our question mark. So when we do that, we'll notice that our angle degree is going to be 40 degrees. Next, we're going to talk about tetrahedrons. Really not too bad. It's connecting the points. If you'll notice, we have a cube right here. We're wanting to connect the points D, E, G, H. And this kind of gives us a little idea of what a tetrahedron looks like, and so on. So when we connect our points D, E, G, H, we kind of get a figure like this. And this is going to be represented as a tetrahedron. And here in just a second, we are going to just kind of get a little visual of what it looks like. And I apologize ahead of time. I did not connect D and G or H and E, but it's pretty much going to create a certain image whenever you go and connect the points. And we'll go ahead and look at that in this next question with our Schlegel diagrams that we're fixing to talk about. So if you'll notice for question number 6, tetrahedron is the first one we're supposed to solve for. We're going to go ahead and pull that image up. And if you'll notice, if you look at this image right here, and then you look at our last one, when the points are connected correctly, not like what I just did, you're going to get that image right there. And that's going to represent a tetrahedron. The same thing goes for an octahedron. If you have a really big shape, you're connecting a lot of points, it's going to look like that once you connect all the points. And then the same thing would go for, say, an isosahedron. When you connect all the points you need to connect and you get your image created, it's going to look something like this, which is a little more complex, but shows the basic idea of the higher you bump up, there are a lot more steps involved. So that is going to be it for this lesson. I hope you enjoyed watching. I apologize for my computer moving around a little bit. It's I don't quite have a desk yet, so we're going to roll with it. I hope you guys have a mathematical day, and I'll see you next time.